Sorry, my computer just like totally shut off on me.
I'm sorry.
No, yeah, it just lost all my tabs and everything like that, and it just like closed out. So I gotta open the book pages back up. Sorry,
Okay.
that's weird.
As long as you weren't just mad and hung up, right?
No, no. Yeah, I was just furious at you, because yeah,
You don't like perpendicular chords.
I was upset that they gave me a problem about that. So, so
All right, so we were on step 3,
mhm.
the DEBE part, and I went ahead and typed it in because we talked about it, but I didn't write it. So the reason DE and BE are congruent is because AC, that diameter, it crosses the chord DB and they meet at a right angle. When that happens, when you have a diameter that meets a chord at a right angle, it splits that chord in half, and it actually splits that arc in half too. We might need that. It's going to make, oh, let me get my pen again, sorry. It's going to make these arcs here congruent too. That's what a diameter does when it crosses a chord at a right angle.
Okay. What theorem is that? What postulate or
It's,
whatever?
it's called Theorem 5 on 655 in the book.
Okay.
I typed kind of like a short version of it there.
Okay.
You can use symbols too. You could use the symbol for perpendicular. Um, I was just typing it, so I couldn't put the symbol in.
Yeah, I got you. So, AE equals AE. We've learned that already.
Mm-hmm.
Congruent AE. That would be reflexive, right?
Yes, you're right.
Awesome.
Mark it up here. AE. All right, so then it says triangle AED. So that's the triangle on the left. It's congruent to AEB, which is the triangle on the right. How do you know those two triangles are congruent?
Because of the um,
Remember, there's only certain reasons triangles can be congruent with the A's and the S's and the H and the L.
the hypotenuse and leg theorem.
That is a possibility because they're right triangles, but we don't have anything marked on each hypotenuse, so it can't be that one.
Um, well, I know this because the um, the chords are congruent, everything, and arcs are like I know everything's congruent. So
Well, look what's marked though from the steps above so far, from steps 1 through 4. Look
mhm.
at what's marked on the triangles. The longer leg is congruent to the longer leg because those red marks. And then we had the two right angles. My funky blue on the left, but it's supposed to be a right angle. And then the short legs, because in step number 3, we said that those short legs were congruent.
So
So by what's marked, how are those congruent?
well, wait, I'm kind of confused.
Here, I'm going to draw them separate over here. So here's the left. I'm just separating them.
All right.
Here's the right. They're
Mhm.
both right angles. And I have those red marks in the middle. And then the bottoms are marked like this. How are those two triangles congruent?
Uh,
We got two sets of sides and a set of angles.
It's not hypotenuse leg, but it looks like it.
If it was hypotenuse leg, I'm going to get another color just so it won't be the same. It would have to know about these, right?
Yeah.
But we don't know those yet. So we can't use that if we don't know for sure.
So all the legs are congruent and the angles are congruent.
And the angle is between the two sets of legs, right? So side angle.
Side. Oh my gosh. Throwback.
Hang on one second.
All right.
Okay. All right, sorry. Yes, side angle side. All right. Reason number 6 says corresponding parts of congruent triangles are congruent. Do you remember our short way to say that?
C, 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 C.
Too many C's. C.
Or what? Yeah. Yeah.
What is it? CP.
C, T, C.
There you go. So that's the same as number 6. I'm just showing you. Sometimes they write it out with all the words, but we just use the abbreviation. So now in those two triangles, we've marked that the legs are congruent, and you kept wanting to say that the hypotenuse was congruent to the hypotenuse. So if you look at step 7, I know I'm skipping to 7. We're coming back to 6. But at step 7, they're saying that AD, which is here, is congruent to AB, which is here. Congruent chords cut congruent arcs. So if I want those arcs to be congruent, which chords need to be congruent?
AB and AD.
Mm-hmm. Why do we know they're congruent now?
Because, well, is that because of hypotenuse or the CPTCC?
Yeah.
Yeah.
Now that we have these two triangles and we know they're congruent, we know that all their parts that match up are congruent. So we can say that the hypotenuse is congruent to the hypotenuse because of CPCTC. So in step 6, we're going to name those chords because they're part of those triangles. Does that make sense?
Yes, ma'am.
So AD is congruent to what?
To AB.
Mm-hmm. And in step 6, we're naming the segments because we're talking about parts of the triangle. And then in step 7, we know that the chords are congruent. Why is that?
Because of the hypotenuse leg.
No, that's why triangles can be congruent.
Oh, wait. This is one of the new theorems, isn't it?
Yes. Congruent chords. Page 654, theorem 10.3. But how did I say it?
You said it is like congruent. Wait, you said congruent chords.
Congruent chords do what? Remember my 2 ninja knives and I was cutting my pie?
Congruent. I'm racking my brain trying to remember.
Congruent chords cut congruent. One more word.
Congruent chords cut congruent angle or arcs or angles or whatever.
Arcs.
Yeah, arcs. Yeah.
Congruent chords cut congruent arcs. So up there in our picture, AD and AB, those are the chords that are like the knives coming down. And so they're cutting those blue arcs off exactly the same.
All right, there we go.
All right, hang on one second, Braden, okay?
Okay.
Okay. Do you feel good about 17 now?
Yes, ma'am.
You sure?
I'm not great all the way sure, but I feel better about it than I did when I started.
All right. Go back through it and look at the picture and look at the steps we've done, like not right this second, but in a little bit.
Yeah.
Go back and see if it makes better sense once you look back at the picture and the steps we did.
Okay. Then I'll try 18,
Okay.
and then if I need your help, I'll let you know.
Okie dokie.
Alrighty, I did that one. So I'll tell you what I got, and you can tell me if it's right or not, I guess.
Oh, okay, just 1 second. What is it, bud? Lego Man. Lego Man? Yes. All right. Okay, what you got?
For number 1, I got given.
Yes.
Number 2, I got PT, like chord PT is congruent to chord QS.
Let's see. PT. Yes.
Okay. Number 3, I got CP/CTC.
No, because you don't have any congruent triangles.
Oh, okay.
In order to do that, like, let me share the screen again. Let's see. All right, in order to do that, like in number 17, we had step 5. Oh, I need my pen, sorry. We had step 5 that showed that 2 triangles were congruent. You have to have a step like that before you use CP/CTC.
Oh, okay.
But look at those 4 pieces. UP, UQ, UT, and US. All 4 of those pieces are what in this circle?
Part of the triangle.
Think of them with the circle, not the triangle, for a minute. See if you can see what they all have in common.
Oh, they're chords.
Yes. No, they're not chords. They all stop at the center and the side of the circle. What kind of
Oh.
segment goes from the center to the side of the circle?
A radius?
Mm-hmm. And what do you know about any radius in a circle?
Uh,
I could draw 10 more in that circle, and what would be true?
that's congruent to the arc angles.
No, they're all congruent to each other.
Okay.
Anytime you draw a radius within a circle, it's got to be the same length, right? Or else it's not a circle.
Uh-huh.
So, you can just explain that in words. You can say that all radii are congruent in a circle. Oh boy, my pen went wonky. Radii is just the plural for radius.
How do you spell radii?
Radii.
Oh, okay. So I don't know if the CTC messed me up for number 4, but I got a side congruence.
That is correct.
Awesome.
Very good.
Thank you. And then for number 19, I don't know what that one would be.
Let's see. Briefly explain what other congruence possibly could be used to show that DT is congruent to QUS. Okay, this one, all the other ones besides side have to do with angles. So in those two triangles, you could know about the angles back from, I want to say section 10.2, where the central angle, remember central, let me get another color. The central angle is like this because it has its point at the center. So there's one central angle. Here's another central angle. The central angles tell you the arc measure. So because those arcs are congruent, those central angles will be congruent. So this angle will be congruent to this. Does that make sense?
So it would be central angles theorem.
I don't know if there's one called that, but you could kind of word it that the congruent arcs have congruent central angles. That would be one step. And so if you had that step, then you could use like side, angle, side, using those blue and the red that's marked on those triangles.
Mm-hmm.
But you'd need a step. Let me look back in 10.2 and see what if it has a name or if it's just one of those numbered ones. Let's see.
Okay.
No, it's just kind of how central angles work. So it's kind of like a definition. So you could just word it out. You could say that the arc measure is the same as the central angle.
Okay.
Let's see how they worded all fancy. I'll scroll down. Yeah, side angle side. That's what they did.
You can keep that up on the screen if you want.
No.
No, I did it all. I was just gonna check it, but
Are you done?
yes, ma'am. No, I can wait till tomorrow. I don't need to do it.
Okay. Did you finish all of them?
Yes, ma'am, I did.
All right. You can check. It's fine because then if you missed it, we can go over it.
Okay. And I did have a question on the book section, page 660.
Uh-huh.
Yeah, I think it was on number 3.
Oh. Did you draw a picture?
I did not draw a picture. That should have been something I did.
Draw a picture. Somebody emailed about that one yesterday, and I drew a picture. I can put the picture on the screen, but draw a picture. Oh, buddy. You wear your Wally shirt?
Yeah.
We'll wear it later, okay?
Wally shirt. Wally shirt.
All right.
I got 13,
Wally shirt.
14 wrong.
13 and 14. All right. Are you finished looking at the other ones? Okay, please.
Let me just mark these off real quick.
Oh, I see. You have a Lego man?
Yes.
Number 19. Okay, so I just missed just 13 and 14.
All right. Roll back up. Let's see. Is PR a diameter of the circle? Okay, in order for it to be a diameter using the pictures they've drawn, you have to know that it cuts the other chord in half, so it bisects the other chord, and that it's perpendicular to the other chord.
And okay, I see that.
It has to meet both of those qualifications.
Okay, I understand that.
Yeah, so 13, you would have to know this, and
Yeah,
this would be
that's
true.
right.
And this one, you'd have to know this. All right, 660. Whoa, Zoe. Let me get that on the screen. Just a second. You're so loud. You're so loud. Sorry about that.
Yeah.
Yeah. Sorry. Okay, can you see it?
Yeah, yes, ma'am.
So number 3 is telling you about some arcs. So you need a circle. And then I know the EFG is 195, so it's a little bit bigger than a half circle. So when I drew it, what I did is I did like this, and I knew it was a little bit bigger than that. So I went to, I don't know, maybe right there. That's probably too much, but G. First off, do you understand why I did it like that? Yes or no? Maybe, possibly.
Sorry. I was writing it down. Sorry.
That's okay.
What'd you say?
So when I drew it, I knew that it was a little bit bigger than a half circle because it's 195. So that's why I put the E up there above the half mark.
Oh, okay.
Because I knew it was a little bit bigger.
Yeah.
It's still not to scale or anything. I just knew that it was a major arc because it was bigger than a half circle.
Okay.
So all of that is 195. And then EF, just this, is 80. And it wants you to find FG and EG. So FG would be this part. How could you find that blue part?
You're gonna do 195 minus 80,
Mm-hmm.
which will get you 115.
Yes. And then EG is,
195 plus 80.
well, EG is over here. Remember, if it's two letters, where is it? If it's two letters, it's the shortest distance between those two letters.
Okay.
There might be other things in between, like maybe there's an H here or something, but you go the shortest distance from E to G. So how would you get that?
80 is 275. 360 minus 275. Or wait, no. It would be 275. No.
What do you need to subtract? You can do this.
So the whole circle is 360.
Mm-hmm.
And 275 is already taken up.
No.
No.
That 80 is part of the 195.
Gotcha. So it's really
195 is all the way the other side from E to G.
So it's just 360 minus 195, which is 165.
There you go.
Awesome.
Did you get number 4?
I got 83 degrees. That's probably wrong.
Don't doubt yourself.
Yes, I do doubt myself.
It's not right, but let's see why it's not right. Did you draw a circle?
No, that's why I didn't.
Then it's okay to doubt yourself a little bit because you should always draw a circle if there's not one. All right, so I'm going to draw a circle. Really bad circle. Okay, bud. So here's the circle. Circle C, it tells us. So C's in the middle. Points A, B, and D are on the circle. AB is congruent to BD. ABD is 194. What's the measure of AB? All right. So ABD, let's start there because we got a number. ABD is 194. That's really similar to number 3. That was 195. So I'm going to kind of draw it the same way. I'm going to say, I know that it's a little bit bigger than a half circle. So I'm going to put A up here. And I'm going to wait on B. I'm going to put D over here. I'll tell you why. It's telling me some more information right here about B.
Okay.
So before I place B, I want to make sure I put it in the right spot. Okay. Okay, buddy. Sorry. All right. So it says this whole thing, all that is 194. And then I'm going back to this AB thing. AB is congruent to BD. So where should I place B?
So right, like a little bit to the left of 194.
Yes. How come?
Because if it's right next to the line, like, you know what I'm saying, like the diameter looking line,
Yeah.
it's going to be congruent. I mean, it's not going to be congruent to anything but AB. So if it's equal lengths from each side, then it's congruent to each other.
There you go. So now we know that this And like I said, they don't usually put tick marks on the arcs, but I'm doing it just so we can see what we're doing. It's congruent to this. So just on the drawing part, is that making sense?
Yes, ma'am.
Okay. So then it says, what's the measure of AB? How can you figure out how long AB is?
You divide 194 divided by 2.
Exactly.
Yeah, 97.
You got it.
Cool. Thank you.
You're welcome. If you think of something else, you can always email.
Okay, thank you.
You're welcome.